Hello guys, this is the 8th lecture of the chemical kinetics. In the previous lecture, I have teach you about the zero order kinetics. In today's lecture, I will going through the first order kinetics. If any reaction which is A gives product, all the derivation and everything for first order kinetics, I will be cover this type of reaction. A gives product. If there is something different, that is about there is some stoichiometric coefficient of A, then the rate integrated rate law and your T half TLF, actually half lifetime, half lifetime and lifetime of completion of the reaction will be changed. Okay, so I will cover only the A gas product type reaction, and this topic is very important actually because many of the question, 99% of the question will come from the first order kinetics. Okay, so if the reaction is A gas product, then rate of reaction will be written as rate of reaction is equal to ROR is equal to R is equal to K concentration of A ki power 1, where in zero order kinetics, for where zero order kinetics, R is written as K A ki power 0. It means rate is equal to K, which is rate constant, which is equal to constant value. So from here we say for zero order reaction the graph will be look like for rate versus concentration. Rate versus concentration for zero order, it is constant value for zero order reaction. Zero order. Where for first order reaction, we can see that rate is proportional to concentration, initial concentration, that is A ki power 1. So since for any type of reaction, product is formed and reactant is consumed. So reactant consumed and product formed for any type of reaction. So if at time as time increases, at, as time increases, reaction concentration, that is if I call is A, it will decreases, and product concentration if I call it P, it will increases. This is valid for every reaction, every order reaction. Okay, so if concentration decreases as time increases, it and rate is proportional to the concentration, then it means as time increases, our rate is also decreases. Okay, rate is also decreases for first order reaction. So for first order, rate is also decreases as time increases. But for zero order reaction, we see that rate is constant. As concentration decreases of reactant decreases, rate is constant. Rate does not change. Rate is constant. So in first order reaction, if I make a curve for rate versus reactant concentration, rate versus concentration of reactant, concentration of reactant, it will increase linearly because R is K, sorry, R is K into A. If I compare it is Y is equal to mx plus C, where C is 0, so Y is equal to mx, then we can say it is a straight line with a slope of K. Slope of theta, that slope of tan theta is equal to K. Okay. So for first order reaction, the curve of rate will be look like this. Okay. Then For zero order reaction, then we have solved for integrated rate law. So similarly, for first order reaction, we will solve integrated rate law. Integrated rate law. Okay. For integrated rate law, if any reaction A gives product, uh, if reaction of type of A gives product, then rate can be written as R is equal to K concentration of A, and from the first lecture of chemical kinetics, we can write rate is equal to minus 1 by 1, that is stoichiometric coefficient of the reactant A, dA by dt. Okay, both rate are same, then we can write minus dA by dt is equal to minus K, sorry, minus no, is equal to K concentration of A. Now dA by A is equal to minus K dt. Okay. Then we have to integrate it, and we assume let at t is equal to 0, concentration of A is A naught, and at t is equal to T, concentration of A is A. Okay, so we will integrate it dA by A with A naught to A minus K dt with 0 से T. So we know that integration of dx by x is log base E x. So we can write log base E is equal to ln x. ln x. So we use this analogy in this page. Then we have ln A, which goes from A naught to A, minus K is constant. It not depend on the time. So K will be out of the integration part. So integration of dt is T from 0 to T. So we will write ln A minus ln A naught. A minus A naught is equal to minus KT. So, and actually, we don't know the value of ln2, ln3, but we know the value of log 2. So we convert the ln factor to log factor. The conversion fraction is ln x can be written as 2.303 log base 10x, or we can say 2.303 log x. Okay, so we convert this. So ln A is 2.303 log A is equal to 2.303 log of A naught minus KT. So divide by 2.303 whole equation. So log A is equal to log A naught minus KT divided by 2.303. So the final equation is log A is equal to log A naught minus KT divided by 2.303. Yes. If we made a graph from this equation, I will make graph here only. Graph of log A, log A versus time. So if you compare it from y is equal to mx plus c, then c will be your a naught log a naught and m will be minus k by 2.303. Okay, so with the negative slope. Okay, so graph should be like this. And the intercept will be log a naught and slope, if this is your theta, then tan theta will be minus k upon 2.303. Okay, so if there is a question in the competitive exam or on your board exam and it is written like uh, the concentration, if for a given reaction A gives product and the concentration of A is linearly decreased with respect to time, and only this is given and all the data, then all the data are given and you have to find the order of the reaction and the rate constant, and the thing given is your concentration decreases with respect to time, then it means it is a zero order reaction. But if it is written the log of the concentration is decreased with respect to time, then we can say it is a first order reaction. So the slightly difference between the zero order reaction and the first order difference, that is the graph for zero order reaction, your concentration will decrease with respect to time, when for the first order reaction, your log of concentration linearly decreases with respect to time. Okay, keep in mind that. Then actually we have lot of form for this first order reaction rate law. We have a lot of form. This rate form we will now use for to solve question. The form we will use to solve question I will discuss here. Other forms of rate law. So first form is used to solve used to solve numericals. Numericals. Other forms of reaction used to solve numericals. So we will use the same form, that is log A is equal to minus kt divided by 2.303 plus log A naught. Then we have this log A naught minus log A is equal to kt divided by 2.303, and if we use formula log A minus log B is equal to log A by B, so from that formula we can write log A naught by A is equal to kt 2.303. So from here we can write T is equal to 2.303 divided by K log A naught by A. So this is the formula we will use to solve question. So लर्न दिस फॉर्मूला, इस फॉर्मूले को आप रट लीजिए, ये फॉर्मूला बहुत इंपॉर्टेंट है, यही फॉर्मूला में यूज करना है न्यूमेरिकल को सॉल्व करने के लिए. ओके, नेक्स्ट वी हैव वन अनदर फॉर्म. इस फॉर्म को याद मत करिएगा, बट ये फॉर्म से आपको ये पता चल जाएगा कंसंट्रेशन आपका टाइम के साथ कैसे डिक्रीज होती है। सो अगर हमारे पास है फॉर्म, हम एल एन के फॉर्म को लेते हैं, एल एन ए इज इक्वल टू एल एन ए नॉट माइनस के टी। सो वी कैन राइट एल एन ए माइनस, सॉरी सॉरी, ए माइनस एल एन ए नॉट इज इक्वल टू माइनस के टी। So we can use the formula of ln A minus ln B is equal to ln A by B. Then ln A by A naught is equal to minus KT. So A is equal to A naught e की power minus KT. Okay. So this is exponential form of exponential form of concentration. Concentration. Okay, if we make a graph for this, so how the graph will look like? How concentration is a concentration a decrease with respect to time. So concentration of A with respect to time. Okay, concentration of A with respect to time. So how the graph will look like? At t is equal to 0, if we put at t is equal to 0, then what is the a? At t is equal to 0, e की power minus 0, that is 1 upon e की power 0, that is e की power 0 is 1, that is a is equal to a naught, which is correct. And at t tends to infinity, so t tends to infinity, e की power minus infinity, 1 upon e की power infinity, that is 1 upon infinity, that is 0. So a tends to 0. सो हम लोग ने यही एज्यूम भी किया था जब हमने ये इस फॉर्म को इंटीग्रेटेड लेटर निकाला था। तो इस लेटर निकालने में जो हमने लिमिट्स लिए थे, लिमिट्स यही लिए थे, टी इज इक्वल टू 0 पे ए इज इक्वल टू ए नॉट होना चाहिए, टी इज इक्वल टू डी पे ए इज इक्वल टू ए होना चाहिए। तो एट टी इज इक्वल टू डी पे तो ए इज इक्वल टू ए है, और एट टी इज इक्वल टू 0 पे ए नॉट निकल के आ रहा है, मतलब ये सही है, इक्वेशन इक्वेशन सही है, तो इससे हम ग्राफ निकाल सकते हैं। तो एट टी इज इक्वल टू 0 पे हम आएंगे ए नॉट पे, तो ये हो गया आपका ए नॉट। और एट टी इज इक्वल टू इन्फिनिट पे टेंस टू 0 करेगा, और जो डिके होगा वो होगा एक्सपोनेंशियल डिके। सो इट इज लुक लाइक दिस। सो दिस ग्राफ इज योर a is equal to a naught e की पावर minus kt. Okay, this is your exponential decay of first order reaction concentration, reactant concentration with respect to time. Okay. Okay. Then after that, in zero order reaction, we will talk about the half-life of reaction. So in the first order reaction, we will talk about half-life of the reaction. So half-life of reaction, which is written as T half. So definition is time in which reaction completes 50%. Reaction completes 50%. So if reaction A gives product, so at T is equal to 0, A is A naught, product is 0, and at T is equal to T half, A should be A naught by 2. Okay. So which form will we use? We use this form. T is equal to 2.303 by K log A naught by A. Okay. So we will use this form to get the T half. So formula is T is equal to 2.303 by K log initial concentration by final concentration log A naught by A. Then T half is equal to 2.303 by k log a naught by a naught by 2. So a naught cancelled, so log 2. So t half is equal to 2.303 log 2 divided by k. So what is the value of log 2? So I will write some values of log term. So you should remember these values. Log 2 is 0.3010. Log 3 is 0.48. Log 5 is your 0.69. I guess 1 minus 0.3010. So 0, 9, 9. So it should be 0.699 approx 6990, and log 7 is approx 0.85. So learn only these four values, and after, if log 11 and log any other term will come, so it will be the value of that term will be given in the paper, exam paper. This four term you should know, and this is literally approx value. So the question will be objective type, so you should get the answer near about answer. So you can easily get the actual answer. Okay, so T half is your log 2.303 log 2. So if we write 2.303 multiplied by 0.3010 by k, it comes out to be 0.693 by k. So T half is equal to 0.693 by k. Or we can directly say this term is 2.303 log 2 is ln2 or log base e2 by k, or we can write ln2 by k. So we can also write it ln2 by k here. Uh, 0.693 by k or ln2 by k. Both are the same. In book you will see 0.693 by k, but in the physics book, in the chapter of radioactivity, where radioactivity element have will follow the first order kinetics, you will get ln2 by k. Okay, so this is the T half, and if we compare from zero order reaction for zero order and first order, zero order reaction, we know T half is your A naught by 2k, whereas for first order reaction T half is 0.693 by k. So here we can say T half is proportional to initial concentration. So T half is directly proportional to initial concentration. Initial concentration, whereas in first order kinetics, T half is constant. It only depend on the rate constant. So for zero order reaction, we can say that if the initial concentration is less or more, T half is less or more. But for first order reaction, T half is constant. It does not depend on the initial concentration. So it does only depend on the rate constant, and rate constant for particular reaction is constant if the temperature of the reaction is constant. Okay, so simple. The For first order reaction, we have a constant half life of reaction, where in zero order reaction we have half life, which is a function of initial concentration. Okay. Then we have studied about the lifetime of reaction. So lifetime of reaction. It is represented by TLF, or lifetime is time in which reaction reaction completes 100%. Okay. If we have a reaction, A gives product, then at T is equal to 0, it should be A naught, and product is 0, and T is equal to T half, it should be A naught by 2, and T is equal to TLF, it is 0. Okay. So if we use the equation, T is equal to 2.303 by K log A naught by A, then TLF is equal to 2.303 by K log A naught by 0, which is infinity. So TLF goes to infinite. So it means first order reaction never completes. First order reaction never completes. Okay. So you should say that if any reaction follows the first order kinetics, it means your concentration will not goes to 0. But in zero order reaction, your concentration may goes to 0. Actually, in zero order reaction completes, and the TLF will be A naught by K for zero order reaction. But in reality, you can say that uh, reactant it's fully converted into product every time. So actually, this is mathematics. This is not actual. This is mathematics. We have some, done some math behind it, and from the mathematics comes out to be, if any reaction truly follows the first order kinetics, uh, it will never complete to 100%, or it will take infinite time to convert the 100%. But in reality, all the reaction, every reaction will not actually follow the first order kinetic. It is a mixture of something. So that's why you can get a fully converted reactant or fully formed product in realities. That is the reason. But if any reaction truly actually follow the first order kinetic, then it will never convert to 100%. It will take infinite time to take convert to 100%. So that's it. And then we have some graph of the first order reaction or first order kinetics. Graphs of first order kinetics. Graphs of first order kinetics. Okay. So we have first graph is rate with respect to concentration of reactant. Rate. So first we have write all the equations here. So we will get the graph correctly. R is equal to K A k power 1. Then we have t is equal to 2.303 by k ln, sorry, not ln, it should be log a naught by a. Then we have ln a is equal to ln a naught minus kt. In terms of log a is equal to log a naught minus kt divided by 2.303. And then we have t half is equal to 0.693 by k, and t lifetime tends to infinite. And one more equation, a is equal to a naught e to power minus kt. So we have these formulas or equations. So rate with respect to concentration of reactant. Concentration of reactant. Rate with respect to concentration of reactant, we can use the first formula. And the first formula we have, rate is linearly increases with respect to concentration, and the slope, which is theta, angle subtended by the x-axis from anti-clockwise is theta, so the slope is tan theta. So tan theta is equal to rate constant k. Okay. These all are for these all are for reaction of type A gives product. Okay. Now second graph will be rate with respect to time. Rate with respect to time. So how to define rate with respect to time? We know that rate is equal to Ka, and we use this equation for A, and rate is equal to K A naught e to power minus kt. So we have rate is a function of time. So rate will decrease since rate is a function of reactant concentration. Reactant concentration decreases with respect to time, so rate also decreases with respect to time. Initially rate is high, and it will decrease at time increases. So we need equation that relates rate to time, and this is the equation which relates rate to time. And from this equation, if we say at t is equal to 0, rate should be t is equal to 0, 1 upon 0 is e to power 0 is 1, k a naught, and at t is equal to t tends to infinity, so e to power minus infinity, 1 upon infinity, it is 0, so rate tending to 0. So it means it will look like this only, where this value is your k naught, and the curve is your r is equal to k a naught e to power minus kt. Okay. Now the third third graph. Third graph is simple, your log of concentration versus time. Log of A versus time. So we will use this equation, and from this equation we have, it is y like this graph. So which is log a naught, and if this is your theta, then slope is equal to tan theta is equal to minus kt divided by 2.30, sorry, minus k upon divided by 2.303, not kt. So if this type of curve you have given, that log of concentration of reactant respect to time is decreases linearly, so you can say the order of reaction is first order, and the slope you will get minus k upon 2.303. Sometimes graph should be in terms of log base e, not log base 10. So what happened then, if the graph is ln a with respect to time, it should decrease with respect to time, because we can use this equation. The only difference is that we have here is ln a, intercept is your ln a naught, and if this is your theta from anti-clockwise, then slope is equal to 10 theta is equal to minus k, not minus k divided by 2.303. Okay, so this two curve may be given, or you have this curve also. If like equation like this, question will come according to this. Select the wrong answer for first order reaction. So first given is your rate is linearly increases with respect to the time. First given this. Second is your rate increases linearly with the concentration of reactant. Third given, your rate is exponentially decreased with respect to time, and the log of concentration of the reactant is linearly decreased with respect to time. So which is false? False is first option, that is your rate is linearly decreased linearly increased with respect to time, because for first order reaction rate is exponentially decreases with respect to time, not linearly decreases with respect to time. So these graphs are very important, because from these graphs you can easily tell the reaction is first order or zero order. For zero order reaction, rate is constant with respect to time or with respect to concentration. But for first order reaction, your rate with respect to concentration linearly increases, but with respect to time, it is decreasing, exponentially decreasing. Okay. Then we have curve number fifth, and curve number fifth is your concentration of reactant with respect to time. Concentration of reactant, concentration of reactant with respect to time. So for that, we will use this equation. For this equation, we have exponential decay. So exponential decay of type this, where this should be a naught. This graph should be a is equal to a naught e to power minus kt, and it will goes to 0 when time goes to infinite. So that's why we have a parallel line. Sixth graph, which is graph of t half. So t half, if we say for zero order reaction, what is the graph of t half for zero order reaction with respect to initial concentration? Okay, initial concentration. Initial concentration. What should be graph for zero order reaction? Zero order kinetic. For zero order kinetic, it should be like increasing graph. And if this is your theta, then tan theta is equal to 1 by 2k, because t half is a naught by 2k. And if for a first order reaction, or For first order kinetic, we have T half is equal to 0.693 by K. And here we have initial concentration. Here we have T half, and it should give us constant value because T half is constant here. That's why we have a constant value. And we have one more and last curve, and this should be product concentration with respect to time. Concentration of product with respect to time. So product के लिए कैसे निकालेंगे? Let us consider we have A gives P. So A T is equal to 0, A should be A naught, P is 0, and at T is equal to T, X from A naught is consumed and P make X mole. So from equation we have A is equal to A naught e की power minus kt. We have this equation. So at T is equal to T is A naught by X is equal to A naught e की power minus kt. We have to find X. So then we will have A naught minus A naught e की power minus kt is equal to X. So X should be A naught 1 minus e की power minus kt. So at T is equal to 0, X should be T is equal to the e की power minus 0, that is 1 minus 1 0. So it should be 0. So यही हमने assume किया था कि T is 0 पे P 0 होना चाहिए. And at T is equal to T tending to infinity, and T tending to infinity, e की power minus infinity, that is 1 upon e की power infinity, 1 by infinity, that is 1 by infinity is 0. So X tending to A naught. So at T is equal to T infinity, X tending to A naught. So up now we have two type of curve here. So which will be true? Now we know it will start from 0 and goes to A naught. So we can have this also, and we can have this also. So which is true? This slope or this slope? So we can see at T is equal to infinity, X tending to A naught. It means T tending to infinity, X going to A naught. It should go A naught at T is equal to infinity. But here at finite T we will have A naught. So this is wrong. So we have slope of this at A naught, and we have, if this, then the curve should be like, so we have concentration of product with respect to time curve like this. Okay, so for first order kinetics, these are the 7 important curves which are these are the 7 curves that are important. So if you have any one type of curve, you should know which order kinetics the questions talk about. If the rate is increases linearly, then it with respect to concentration of reactant, it means first order kinetics. If rate is exponentially decreasing with respect to time, it means the first order kinetics. If log of concentration is linearly decreasing with respect to time, there is first order kinetics. Or concentration of A is exponentially decreasing with respect to time, there is first order kinetics. T half is constant with respect to initial concentration, first order kinetics. And concentration of product is increases with respect to time, exponentially increases with respect to time. It means first order kinetics. So we have, these are the important graph, and we have the all the lifetime, half life, and all the forms of first order kinetics, and how to get integrated rate law. The method is simple. uh, Rate is given for the first order reaction, and from the first lecture of chemical kinetics we know that how to write a rate in terms of stoichiometry and instantaneous rate law. It is minus 1 by 1 dA by dt, and from that two equation we have uh, our rate expression, which is in this form, in time form, which is used to solve the numericals. And we will talk about, and then we have talk about the other forms, that is a is equal to n or minus kt. You don't have to memorize this form. Actually, this form only used to get the graph of concentration of a with respect to time, but question we will for question we will use this form. T is equal to 2.303 ln a naught by a divided by k. Okay. Now after that we will solve some numericals. What type of numerical will come from this from first order kinetics, and then we will have some example of first order kinetic. Actually the example that are very important. We have many examples. We have many equation for the first order kinetics, but we will talk about the important example that easily came in the, or that actually came in the exam or competitive exam, any exam. Okay, bye.